When adding and subtracting rational expressions, what we first need to do is factor everything completely. So in this first example, there's nothing to really do here. But in the second one, I can factor out a 4, and that would leave me with a 5x plus 4 in the denominator. Now what I want to do is find a least common denominator for both of these fractions. And I need to account for every piece. So the 5x plus 4 needs to be in the denominator of both fractions. Now looking at the 2x and the 4, the least common multiple of 2x and 4 would be 4x. So I need to also multiply in the denominator by 4x. Now looking from this denominator to this denominator, to get it into the new denominator, I multiplied it by 2, 5x plus 4. So I need to multiply the top by 2 times 5x plus 4. Here, I multiplied it just by an x, so I just need to multiply the top of this by an x. Now I'm going to simplify my numerators. So this gives me a 10x plus 8, and then I multiply that by 7x, so that's going to give me a 7x squared plus 56x all over the 4x times 5x plus 4. Here I have an x squared minus 2x, again all over 4x times 5x plus 4. I'm going to then combine like terms. It's all going to be over the same denominator. So 7x squared plus 1x squared gives me 8x squared. And 56x minus 2x gives me a 54x. The last step, if possible, is to take a GCF out of the top. So if I factor out a 2x, that would leave me with 4x plus 27 over 4x times 5x plus 4. The x's would cancel, and 2 over 4 reduces down to 1 over 2. So my final answer would be 4x plus 27 over, distribute the 2, 10x plus 8. In our subtraction example, we're going to again factor whatever we can. So the x minus 1 over x minus 2 is going to stay. But then the numerator of the second fraction cannot be factored because there's no two factors of -4 that add up to +4 with different signs. So we're just going to leave it the way it is for right now. In the denominator, two factors of -12 that add up to +4 and have different signs would be a +6 and a -2. Now looking at our two denominators, I need to come up with a common denominator to rewrite these fractions. Now they both have an x minus 2, so I can represent that once in my new denominator. But then I also need to represent the x plus 6. Now in the first fraction, to get my new denominator, I multiplied by x plus 6. So I also need to do that in the numerator. So I multiply the numerator by x plus 6. Now, in the second fraction, I didn't change the denominator at all, so my numerator is also going to stay exactly the same. I'm going to simplify my denominator in the first fraction, so FOIL, x squared plus 6x minus 1x gives me plus 5x, and -1 times 6 is a -6. Our denominators stay the same. And we're subtracting. Now, if it helps you to remember that you're subtracting each piece, it may be helpful to write the entire second fraction either with parentheses around it, so you remember to distribute the negative sign, or you can change it to addition and then change the sign of each term inside of the parentheses. But that is 100% up to you. You just have to remember that it's subtraction. So it's going to be x squared plus negative x squared, which means that our new numerator, the x squared cancels out. Then it's 5x plus a negative 4x, so that's going to give me a positive 1x. And a negative 6 plus a positive 4, which is going to give me a negative 2. The x minus 2 then cancels in that last fraction, and I'm left with nothing but a 1 in the numerator and an x plus 6 in the denominator as my final answer. It is very important when you're simplifying an expression, so when you're adding or subtracting two rational numbers, that you get a common denominator. You simplify the numerators, so you combine like terms in the numerators. And then once you're left with just one fraction, that's when you can cancel on the top and bottom. But we can only cross cancel if this were multiplication. So get the same denominators, simplify the numerators, and when you're down to one fraction, see if there's anything that you can cancel out.